accepted.
All right, I really wish that I could have that kind of entrance like when I got home from these kind of trips. I get in the door and all of a sudden there's music playing and all these nice slides. That would actually be fun. All right, well, good afternoon, everyone. And I guess we can consider this afternoon, I guess. We're almost about to eat lunch. But I want to share with you a lot of lessons learned about this thing we call microservices. Now, I'm going to show you the agenda in a bit, but I've been kind of an early adopter, I guess you'd say, of microservices. I started working in microservices about 12 years ago, a little bit before the seminal paper by James Lewis and Martin Fowler that really kind of put a name to this architecture style we had been using. So I want to kind of give you a little journey of some of the things and myths about microservices. There's a lot of places to go to get some more information. As a matter of fact, I've written quite a few books, especially the two most recent ones with my friend Neil Ford. These ones I wrote quite some time ago, and you can actually get access to those through my website. If you just go to developer2architect.com, just click on the books link, and you'll see these, and you can download the PDFs for both the microservices patterns and anti-patterns, I should say, and pitfalls, and also just first book I wrote about microservices was just dispelling some of the myths about the differences between microservices and SOA, because they are two very much different architecture styles. Another place you can go for lots of resources is my website as well under lessons. And every 2 weeks I do a 10-minute video. And as a matter of fact, 35 of those 161 videos out there are about microservices and some aspect. And so this is another place you can actually go to get some more information. All right, let's talk about some of the lessons learned in microservices. And as a matter of fact, we're going to start by talking about this confusing definition, kind of talking about some of the most important concepts and what they really mean in microservices, and some of the things we've learned about those. But then, we're going to talk about granularity. Service granularity is really hard, and it's not a guessing game. This is one of the first challenges that teams face when doing microservices. How big should a service be? So I'm going to show you some of the lessons learned and some of the ways of being able to achieve the right level of granularity in your microservices. The next thing we're going to talk about is that microservices is not a silver bullet. It's not a fit for all situations. And it turns out isomorphism matters a lot, especially in microservices. Now, in this section, I will define what isomorphism actually means and how it applies to this thing we call microservices. As a matter of fact, the next thing we're going to talk about, two more topics, is really about where microservices is today in 2023. And as a matter of fact, it turns out hybrids are actually the new king. And we're going to see some of those hybrids and also a very, very important message that comes out in this section right here. And finally, I'll close up the section by talking about that thing called data. No one likes to talk about data, but it matters a lot. And I want to show you the difficulties that we've learned with dealing with partitioning data within microservices, and also data sharing for fun and profit. You mean, wait a minute, sharing data and microservices, you can't do that. Well, yes, you can. And I want to show you that in the last section. All right, so that's going to be our journey for the next 50 minutes, actually the next 45. So let's talk about this confusing definition, this thing we call microservices. Every architecture style that we can talk about has a particular shape to it. And that's going to matter when we talk about isomorphism. Whether it be event-driven architecture, a modular monolith, these all have various shapes to it. The shape of microservices is single-purpose functions deployed as separate units of software, with each owning its own data. That's the shape of this overall architecture style. And so what we have are client requests that typically come into an API layer, and that API gateway then fronts separately deployed services, each having its own data. Not necessarily its own database, but necessarily, I am the only one who can access my tables. And we'll talk a little bit more about that in this session. Two things that I want to talk about in this topic right here. The first is this word micro. Well, what is a microservice? I mean, we all know, because we're technologists, that micro means small. But how big is small? How small is small? You see, I could have a particular service that has 3 class files. I could have another particular service that has 300 class files. Which one is the microservice? Pretty obvious answer, isn't it? Actually, it's not. Because you see, they're both microservices. Micro really refers to what the service does, not its physical size. That service that has 300 class files does one thing, and one thing really well. It sends email to our customers. Each email that we send is a particular template that is manifested through a class file. So we send close to 300 different kinds of emails to our customers. That's why there's 300 class files. But it does one thing really well. So that's kind of the definition when we talk about a microservice. The other concept that kind of has morphed over the years is this idea of a bounded context. Now, Martin Fowler talked about the idea of a bounded context quite some time ago, as did Eric Evans. And it's this idea of being able to kind of really form a boundary around the particular domain and where those domain models apply. So most of us have been doing domain-driven design and understand this concept of a bounded context. But how does this concept apply to the physical nature of microservices? And this is where some of the confusion lies in these definitions. So let's define really what that bounded context means, specifically when we talk about microservices. Imagine, if you will, this. Each service owns its own data. Well, I need your data. I need your information. So what do? I go and just query it. And so all these services are just querying data all over. Can you imagine if I happen to make a change to that data? I drop a column, I rename a column, I change the column type. Well, obviously, I have to change because it's my data. But all of a sudden, I start breaking services everywhere. Picture this scenario with dozens or hundreds or even thousands of services in your ecosystem. Because it would require changing all of the services that happen to be accessing my data. Oh, by the way, assuming I know that you're accessing my data. This is the idea of the bounded context in microservices. It's to control change throughout our ecosystem. The bounded context in microservices means that the data or the service and all that domain functionality exists and coexists with the structures of how I store that data, as well as the data itself. You cannot access that, only me. So if you need my data, now you have to go and ask for it through a separate contract. Well, maybe it's XML, maybe it's JSON, maybe it's a C# object, who knows? But the point is here, when I make a change to my data, maybe I convert it to a graph database, or maybe I move to a KV database. Maybe I just change the structures. Well, certainly I have to change. No one else does. Because we have a separate contract. That's the idea of a bounded context applied directly to the structural aspect of microservices. That's why it is so critical and so important in this architecture style. Granularity is hard. As a matter of fact, I have a quote, embrace modularity, but be cautious of granularity. These are two entirely separate things. Modularity is about the breaking apart of our systems into multiple parts. Granularity is about the size of those particular parts. And that's where we get stuck. How big should a service be? What really defines single purpose? This is hard stuff. So what I've developed are two different kinds of drivers. And as a matter of fact, back in 2015, I actually coined an anti-pattern called the grains of sand anti-pattern. If you picture a beach, think of the grains of sand. This was my experience in microservices. Teams would say, oh yes, we're going to move to microservices, or we're going to do a greenfield application. And of course, we tried to make every service as small as possible. That's an anti-pattern. And as a matter of fact, the only use this has is for actually sitting on the beach and enjoying maybe a margarita or a pina colada or some sort of nice tropical drink. It doesn't belong in microservices. So how do we determine how big a service should be? Turns out there's two forces at play. There's things called granularity disintegrators. Those drivers that say, yes, you should actually break that service apart, make it smaller. But it has to be balanced with things called granularity integrators. Those drivers that say, oh, no, you should keep that service bigger. And it's balancing these two drivers that basically gives you the right level of granularity. Let's take a look at some of those disintegration drivers. The first and the most confusing is really service functionality. What does the service do? We're taught things should be single purpose, single responsibility principle. If I have a notification service, that's a service that notifies our customers. But I can notify a customer through SMS texting, maybe it's an email, maybe it's even postal letters that we send. Well, what is single purpose? Is the act of notifying a customer single purpose, single responsibility? Or is the act of notifying a customer through email or SMS a single responsibility? Now, I do this quite a bit. And I always, now this is too big of an audience to do this because I can't even see you because of the light here. But if I were to say a show of hands of who would say notifying a customer is single purpose versus notifying a customer through one of those means, Do you know what's interesting? Every time I do this query, it's always the same result. Half of you would say, oh no, it's single purpose. Notifying a customer is single purpose. The other half of you would say, oh no. Each of those means is single purpose. This is why granularity is hard. So, let's make it a little less hard. Because some of the other disintegration drivers you could use is code volatility. Is there a place in the code, one of the functions in that service, that changes more rapidly in that code than other areas? If we can extract that code out into another service, I've got a smaller testing scope, less deployment risk, and I'm also not disrupting other functionality when I do a deployment. Another one happens to be scalability and throughput. Do areas of that service scale differently from others? Oh, a good example is our notification service, because we send out 220,000 texts a minute. 220,000 texts, SMS. But we only send out 500 emails a minute, and only one postal letter a minute. That single service now has to scale to 220,000 requests, even though email and postal letter don't need that kind of scalability. And this impacts what we talked about yesterday, which was mean time to start, MTTS. Be able to react quickly when the need is there for additional scalability or elasticity. Fault tolerance is another really good driver to break apart a service. Are there areas of your service that fail more than others? Because when that fault occurs, it's bringing down all of us in that service. But if I can partition that service so that I isolate those faults, this functionality over here always works perfectly fine. That's where the fault is. And that mean time to start, MTTS, comes up again. Because if I do have a failure, I've made that service smaller. So a lot of times, the customer doesn't even know a failure occurred because the startup time or the mean time to recovery is so fast. A final disintegrator might actually be access restriction. If I've got sensitive functionality in a particular service, but that service has a lot of functionality, I have a chance of actually gaining access to information I probably shouldn't. Better to have that access control at an API gateway rather than inside service code. Breaking apart a service like that allows us to separate sensitive information from non-sensitive information. So these are some of the things we can actually demonstrate and measure. It's not a guessing game. We can measure all of these pieces. We can measure scalability, fault tolerance, code volatility, and have a good justification for breaking a service apart, making it smaller. Oh, but not so fast. Because when we start breaking services apart, we no longer have a database or ACID transaction. And now we are in distributed transaction world, where we have to rely on eventual consistency patterns, rely on compensating updates, all of these complex aspects of distributed transactions. Oh, we can break apart a service, but do you remember a couple minutes ago, I talked about that bounded context. Each service needs to own its own data. Oh, wait a minute. If I start breaking apart the service into all these different pieces, I have to break apart the data as well. And if that data ends up being highly semantically coupled to that functionality, bring that service back together. If transactions are more important than code volatility, bring those functionalities back together into a single service. And there's also a third integration driver, and that's workflow and choreography. If I break apart a service into Devoxx, so I've made it 6 services right up here. Oh, but what happens? Oh, well, anytime a request comes in, it comes here, bounces over to here, bounces here, and then this one needs this information, this one goes over here, and now all of a sudden, it looks like a bunch of spaghetti. Highly semantically coupled functionality as well. If that's the case, we take all 6 of these letters, bring them back into a single service. Okay. So it really is, everyone, the balance between these 2 drivers. The disintegration drivers, knowing we should tear apart a service, and the integration drivers, which tell us to put it back together. And now that we have these tools, now we can say, which is more important to you? Is it transactions? Or is it better security? And now we can adjust the size of our services. All right, I did mention that isomorphism does matter, and let's see why. And then I will define isomorphism. Okay, imagine the business says this. We expect constant change in this system here, and we need to get those changes released as fast as possible. Oh, by the way, we also expect significant customer growth in the next 6 months, particularly as we are aggressively acquiring new companies. Well, what do you think? Which architecture style would satisfy those needs? Well, in Neil and I's first book, The Fundamentals of Software Architecture, we developed these star ratings. 1 star is not so good. 5 stars is great. And as a matter of fact, you can go to my website to get these star ratings as well. As a matter of fact, they're in the resource section of my website. But we look at these star ratings for all the various architectures that we could possibly have. And we notice a couple of things. First, this is what's important to us. Agility, the ability to respond quickly to change. That's what the business needs, the ability to respond quickly to change. Deployability, the frequency of deployment. Low risk, and that ceremony involved with deploying our software. Things like evolutionary aspects of evolving our system as we continue to grow the business. Scalability, certainly. We're acquiring businesses. And finally, testability, the ease of and completeness of testing. These are the things that are important. This star rating chart gives us a guide to compare the qualities of one thing to the qualities of another. That's what's important to us here. Do you see some fit? Oh, right here, 5 stars in microservices. As a matter of fact, 5 stars for every one of those things that are important. Now, event-driven and space-based have a couple of them, but it's missing the agility piece, which is important to the business. So what would you say is a really good choice for an architecture to support those kind of business needs? Clearly, microservices. This is its superpower. So, there we go. That was easy. Or maybe not, because then we start building microservices, and this happens. All the service functionality needs other functionality, needs data. And you see, the problem is, this will never, ever, ever work. This is an epic failure. And everything will come crashing down. What happened? We did all of our analysis. We found out what was important to the business. We converted that into architecture characteristics, those ilities. We mapped them to which architecture style fit those. And we're faced with an epic failure. It's because there's one more ingredient. Talk about a lesson learned. and that is isomorphism. Isomorphism is a Greek word. It means essentially iso, which means equal, and morph, which means shape. And there's a term called domain to architecture isomorphism. In other words, does the shape of the architecture match the shape of our problem? Do you remember, I mentioned earlier, every architecture style has a particular shape. Ours, microservices, single-purpose functions deployed as separate units of software, with each owning its own data. What's the shape of your problem? Because you see, most of the time, unfortunately, this is like putting a square peg in a round hole. This is the shape of our problem. Highly semantically coupled functionality. In other words, our problem is the fact that we really can't break up our functionality into single-purpose functions. It's all interconnected. It's all intertwined. That's why it's an epic failure. So this is an exercise, once you find candidate architecture styles, to basically then look at the shape of your particular problem. Is it feasible to break apart your data? Because you have to. It's part of the shape of the architecture. Is it feasible to break apart your functionality? Because that's part of the shape of microservices. And so this is quite a lesson learned about watch out for what's called semantic coupling. Functionality that's related and is needed for every request. Highly semantically coupled data. Data that's all interrelated, especially in relational databases, but doesn't have to be relational databases. These are things to watch out for in microservices. So avoid jumping on the bandwagon and saying, oh yeah, let's just use microservices. Stop, step back a little bit. I just want to make sure I don't fall off the stage. Stop, step back and say, but what's our domain problem? What are we actually trying to solve, and does it fit that architecture? Because there's all sorts of other architectures that work really well. And speaking of that, where is microservices these days? Well, it's falling off, fortunately, of that little hype curve. It's not quite in the trough of disillusionment yet, but it will be. But there's been a coup. So the point is this: microservices is dead. Long live microservices. You see, it's all about hybrids. This is what we've learned. And watch this. So we take a look at microservices. And if we isolate just microservices here, it has a lot of superpowers. Look at all of those 5-star ratings. I mean, this is the choice for high fault tolerance, high scalability, almost everything. High agility, high testability, high deployability, evolving your system. But these are its superpowers. But these are its kryptonite. Poor performing systems. I have been in this industry, folks, for 37 years. 27 of those as an architect. And about the past 12, I've pretty much dedicated most of my career to microservices. Now, I have implemented all the architecture styles, all of them. And I could tell you without hesitation, microservices is the hardest thing I've done in my career. That's how complex this architecture style is. So, here we have a system. It's got customer functionality, it's a monolith, and also admin functionality. It's got a single database. Well, let's break it apart. These are the superpowers. So we say, oh yes, this should be microservices. Or should it? Because look what happens here. So here are the superpowers. Does all this functionality need those superpowers? And the answer is no. Does the back-end administrative functionality need scalability? No. Do we need high fault tolerance? No. Testability, deployability, evolvability, maintainability, agility? No. We don't need any of that stuff. Yet we converted all that to microservices, or even built that as greenfield. You see, the problem is we're not getting any benefit at all in that back-end admin functionality. So, what are we getting? Pain. That's all we're getting. High cost, high complexity, we got to break apart our data, it's going to be slow. We are getting no benefit whatsoever. Hybrids are the new king because of this. Now, I start breaking apart my application. This, by the way, the picture you're seeing here is called service-based architecture, where we still have separately deployed units of software, but they're domain services, not microservices. From here, now we ask, which of those domain services need those superpowers? And it turns out that the front-end customer-facing functionality does. That's where we need that stuff. And we're willing to do that for a trade-off of high cost and poor performance. The poor performance, by the way, happens because of all the latency communicating with other services. Network latency, security latency, data latency. Because I'm making multiple calls of data to retrieve all the stuff I need. However, that should be microservices. But the admin does not. And so this is probably one of the most important lessons learned that I could share with you. And that is this. Not every portion of an application needs to be microservices. Whether you're doing a migration or whether you're doing greenfield, you choose microservices. But be careful, because not every bit of functionality needs this kind of superpower and this kind of complexity and cost. The secret sauce, whether you're doing greenfield, brownfield, or migration, is this. Move to what's called service-based architecture first. We don't have to break apart our data. We can still use monolithic data. But now we have very coarse-grained, large domain services. These are services that contain all of that domain functionality, like customer, like admin, like fulfillment, which handles all of that complexity involved with fulfillment and shipping and all that. Move there first. Then ask the question, which of those large services should we break apart? That is a winning architecture. And speaking of data, isn't it interesting? I consider microservices a highly theoretical architecture style. Let me show you why. So we're told, well, each service must own its own data because of the bounded context. And we get this what's called database per service pattern. Well, it's actually not that hard, because if we have all of our data, all of our tables, we simply apply ownership. Whoever writes to that data owns that data. It's a simple rule. And now we've formed our bounded contexts. What's so hard about that? That, folks, doesn't exist. Oh, if it does, you're lucky. Please call me. I'm available. Because it doesn't. Because what else do we have in that database? We have foreign key constraints. We have materialized views. We may even still have stored procedures, triggers, all sorts of stuff. That couples those tables together. Now, let's form our ownership relationships. Now, let's form our bounded context. Ha! Do you know this would require us to actually cut through every one of those foreign key constraints, every one of those triggers, every view, every stored procedure, and we would actually have to remove all of those in order to form a bounded context. Do you know something very fascinating? There's actually a shortage of DBAs in this industry right now. It's true. Why? Because of microservices. Can you imagine walking up to your DBA, looking them straight in the eye, and saying, we're moving to microservices. We have to remove every foreign key, every trigger, and every view in the database. Just picture that. Here's what happens. The DBA's face starts turning red. It starts shaking like this. And all of a sudden, boom, the head pops right off the shoulders. I mean, it's quite messy, but quite fascinating to watch. Yes. What DBA is ever going to say this is okay? None. None at all. It's not feasible, is it? This is why microservices is so hard. This is reality. So how do we fix this problem? Because we need bounded contexts. Without bounded contexts, we don't have microservices. This is a hard problem to solve. Well, this is the lesson learned. The database per service pattern. Oh, it's interesting. It's cute, but it's not real. We try to achieve this where we can. But reality, folks, is this: data sharing. Oh, yeah. It is absolutely a reality. As a matter of fact, the picture you're seeing up here is what I call pragmatic microservices. Now, pragmatic, by definition, is dealing with things sensibly and realistically. That is a way based on practical rather than theoretical considerations. But Mark, you don't have a bounded context. Oh, but we do. Do you remember the definition of a bounded context? It's the service functionality bound to its data. That's the bounded context. And we have it. It's right here. What we form when we share data is a broader bounded context. Oh, we try to do this with just single ownership, database per service pattern, but in reality, these are the bounded contexts. Now, everything, by the way, I've heard this before. Everything in software architecture is a trade-off. Yeah, that was our first law of software architecture that Neil Ford and I coined in our first book. Yeah, what's the trade-off here? The trade-off is change control. When I make a change to that data, I now have more services that I need to pay attention to and coordinate with that database migration when I release into production. That's the trade-off. I may have trade-offs of fault tolerance because I am sharing a data schema or database. I may have scalability problems. These are the trade-offs of being able to still do microservices but deal with all the highly syntactically and semantically coupled data. These are called data domains. And the lesson learned is they're very useful. All right, so 3 use cases for sharing data in microservices. Use case number 1, what I just described. We can't break apart our data. I mean, for data integrity, we have to keep these foreign keys and views and integrity constraints. Or maybe the data is related. And the fact that also when I break it apart, I need to now access data. And that points to the other 2 use cases. What if we have 2 services that need to update the same data? That's called joint ownership. Whoops. Well, I could try to do a table split, but now I have to communicate between the services. It gets ugly. That's another use case. Because of the bounded context, I can no longer directly access your data, your tables. So how do I get that data? Well, there's a variety of means of being able to get that data. I can ask you for it, I can use caching, or we can simply share the data, so I can still do those necessary joins for sheer raw performance. So these are 3 use cases for why we share data. All right, so one more little addition here. This wasn't in the agenda, but I think we have time for it. And that is another lesson learned about data. But this is not transactional data. This is analytical data. Interesting. So how do we, let me get this focused here. There we go. How do we do reporting in microservices? How do we do analytics? Oh, well, that's a good question, because now we broke apart our data. Oh, I suppose we could go and query the data we need. Oops. Do you see what we just did? We broke every bounded context in our system. And here's the point. One does not simply query microservices databases. It's about the bounded context. Well, this is analytics. This is reporting. I can't ask you for the information. It's too slow. There's too much data. It's just not going to work. What do? Aha! Dum-da-da-dum, data mesh to the rescue. So Zhamak Dehghani kind of created this concept many years ago called a data mesh. And as a matter of fact, I think it's the second to last chapter in our hard parts book, as a matter of fact. And since then, Zhamak has basically written this book about data mesh. Let me show you how it works and addresses yet another problem in microservices, which is reporting and data analytics. It solves that problem, or it doesn't solve it, it addresses that problem. Here's how it works. So let's say that we have a particular service. This is a microservice. We'll call that alpha. A data mesh is in similar context to a service mesh. So every service owns its own envoy. Similarly, every service has its own thing called a data product. This data product is tightly bound with that service. This is a tight contract. And the idea is this. My data needs to be used for analytics. So I'm going to send that data over to my data product. And now that data product is used for reporting and data analytics. Let me actually show you an example. So this is what an ecosystem might look like. Every service has its corresponding data product. Other analytics that's needed now accesses whatever domain data it needs. This is meant to replace data lakes and data swamps, data warehouses, star schemas, all this nonsense that rarely works. No, rather, we have now domain partitioned our analytical and reporting data. So let's actually look at a real example. So this is it's called an architecture kata from our hard parts book, the SysOps squad. Now, this is a trouble ticket system where customers purchase support plans, and if they have a problem with electronic equipment, they can go onto a website and issue a trouble ticket. And then these customer-facing experts, the SysOps squad, come out to your home or office, fix the problem. Okay, let's do some analytics here. So here's our expert service that manages all of our experts in the field, their location, their schedule, their skills, all that stuff. Here is our ticket creation service. That's how we create tickets, trouble tickets. So I've got my data product quantum for experts, and I'm feeding that information for analytics. And also, I've got one for ticket. So that forms its own quantum. And I've got one for ticket creation as well. Now, these are kind of bound together. These know about each other really well. Okay. Well, from the ticket data product quantum, I can generate all sorts of reports and analytics about ticket performance and financial reports. Are we making any money? Which customers or which products are having most problem? I can generate that by querying the data product quantum. Also, here is my expert quantum. So this is my forecasting. What experts am I going to need next year? Well, I'm going to have to do some data analytics. Let's see, I need experts and I need tickets. So that data product quantum now queries the expert data product quantum to be able to get all sorts of expert information about who we currently have, and then tickets. And now I can generate all sorts of forecasting reports on expert skills, who's utilized, who's not, see which kind of tickets are trending, which problems we're having, and now generate all these expert demand reports and forecasting. This is the concept and idea of a data mesh. Fantastic concept. And now, Zhamak is actually putting this into practice. It's really neat, because in microservices, this is yet another problem that we have to solve. Microservices, everybody, is hard. It's very hard. And these are a few of the many. I wish we had a full day. That'd be great. But these are just a few of some of the lessons learned about this thing that we call microservices. So take some of these lessons to heart, and hopefully they'll act as a catalyst so you don't fall into these same kind of traps. So anyways, thank you all so much. Thank you.